In part 1, we looked at arrays of p-vectors and saw how handy they could be. Near the end, we saw an example of this program. Here I'm drawing 3 random curves that are stored as arrays of p-vectors, and I'm just moving the points around randomly from frame to frame. So let's see how to write this little project. First, let's talk about the design, and then we can look at the code. Here's the basic idea. We have our graphics window. I'm going to start by creating just a bunch of random points somewhere in the middle of the window. Notice that they start well off to the left edge of the window and they continue well off to the right edge. That way, when I draw a curve that goes through them all, the curve definitely reaches the ends of the screen. Now really what I want to do is to fill this curve in with blue, but if I just use this as a Catmull-Rom curve and fill it, we'll get this. Processing will join a line from the first point to the last point, and then it will do its best to fill in the pieces. What I really want is to fill in with blue everything below this curve. So the way to do that is to add 2 more points, one in the very bottom left and one in the very bottom right. And these really can be anywhere off screen. I push them way off to the sides and below. Now I draw this curve, and when I fill this in with blue, I get what I'm after. Remember that we're only interested in what's visible inside the graphics window, and if we get rid of all the construction lines, we get our little curve. So this is how I draw one wave, and really I just draw 3 of these. So let's look at the code. Here's the whole program. Using this big font, it takes up 2 screenfuls. So let's just start at the top and work our way down. First things first, I create 3 arrays of p-vectors. And I just call them wavelist 1, wavelist 2, and wavelist 3. Then comes setup. It begins with the normal stuff, size and smooth, and then I decide how many points I want to lay down horizontally to make up one curve. And I chose 40. Now that I know how many points I want, I can actually create the arrays. So for each of the 3 arrays, I call new PVector, and in square brackets, I hand it the number of points I want. Now the arrays are built, I'm ready to fill them in with p-vectors. That's the job of this little loop. Like I often do, I use the letter I for my loop variable. So I runs from 0 to the number of points, and for each value of I, we're going to create one p-vector for each wave. First, I create the x's and y's. The x value I get from map. I take the value of I, and I take it from the range 0 to num points, which is the range of I, to the output range, which is to the left of the screen, minus a quarter times the width. So here the width is 1,000, so that's going to be minus 250, well off to the left of the screen. The right is 1.25 times the width. That's going to be 1,250, well off to the right. And this way I know my values of x start way off to the left of the screen, they go all the way across the graphics window, way off to the right. I made sure that the value for x is so much wider than the graphics window because I know I'm going to jiggle these points around randomly, and I wanted to make sure that for a good long time they would stay off screen. Now I pick a y value. I do this by taking the value of height and multiplying it by a random number between 0.5 and 0.6. That puts it just a little bit below the middle of the screen. Now I have an x and a y. I can create a new p-vector. So I do exactly that. I create a new p-vector with this x and y, and I stick that into the first index of wavelist. Now I'm going to build the other 2 waves by taking this point and moving down. So I'm going to create the first point of all 3 waves. Then I'll create the second point of all 3 waves, and so forth. So I'm not working my way left to right across wave 1, and then wave 2, and then wave 3. Rather, I'm working vertically. I'm going to figure out the first point of all 3 waves, the second point of all 3 waves, and so forth. So for the next wave, the one below it, I decided to start with the same x value, but just move the y value down. So I add height times a random number between 0.1 and 0.2, and that just gives me a point that is below the first one by some random amount. And now I use the same x and the new y to create a new p-vector, and that becomes the first point of wavelist 2. Then I do the same thing again. and that becomes the first point of wave list 3. That's the end of the loop. I go back up to the top, and every time around the loop, I fill in one more point in each of the 3 wave lists. So that's what setup does. Let's take a look at draw. Here's draw. It begins by clearing the background to white. Then I draw each of the 3 waves using a little routine that I wrote called draw wave. I hand it the list of points and a color, and it draws that wave. So I draw the 3 waves, and then I wiggle the 3 waves. My little routine wiggle wave just moves all the points of the wave. And so that's all draw does. It draws and wiggles, draws and wiggles. So let's take a look at draw wave and wiggle wave. Here's draw wave. Take a look at its arguments. The first thing we hand draw wave is an array of PVectors. And so I've given it the local value wave. So we get an array of PVectors first, and then a color. And if we look up at draw, for example, here's our call to draw wave using wave list 1. That's exactly what we're giving it. Wave list 1 is an array of PVectors, and then I hand it a color. So back to draw wave. The first thing we do is we fill in with the color I just handed it, and then I call begin shape, and at the end I call end shape with close. That closes the curve and fills everything in. In between, I create my big curve. I do that by using our standard technique for creating a big Catmull-Rom curve. I just have a little loop that goes through all the points of the curve, and I call curve vertex for every point. And I just pull out the x and y values from the array of PVectors. Once I've added all the points of my curve to the shape that I'm creating between begin shape and end shape, I have to add the 2 little points way down at the bottom right and bottom left. That makes sure that when I fill the area below the curve. So I just add those 2 points in explicitly. The first one is way off to the right and below. The second one is way off to the left and below. Then I'm all done. I close the curve and we're finished. So this draws a wave. Then we call wiggle wave. So let's take a look at that. The first argument to wiggle wave is the same as the first argument to draw wave. It's an array of PVectors. And we know that because we saw earlier we call wiggle wave using each one of our 3 waves. Then I hand it 4 floating point numbers, the minimum and maximum of the random value I want to add to x, and the minimum and maximum of the random value I want to add to y. The loop inside wiggle wave does very little. I simply run through all the points, so I goes from 0 to wave.length. I run through every PVector in the array, and then to the x value, I add a random number. To the y value, I add a random number. And I do that for every point in the array. And that's the program. Looking back at draw, we can see how convenient this all is. We're not thinking about individual x's and y's. We're thinking about points, PVectors. And we can just hand around these arrays of points and do things to them, like draw them and move them. And if we run this program, we get our 3 waves. Because I'm drawing them top to bottom, the highest one appears to be in back. And of course, they're moving around in this crazy way. Just to take a look at what those 2 extra points are doing for us, let's comment them out. So here's the program again. I'm going to come down to draw wave, and I'm just going to comment out the 2 calls to vertex that gave us those bottom right and bottom left points. If I run the program now, this is what we get. It's doing exactly what we asked for. It's drawing this huge curve and then closing it and filling it. It's those 2 extra points at the bottom right and bottom left that give us the effect of getting a fill below the curve. So let's put those back in. So that's how we use arrays of PVectors. I really encourage you to play around with them. Once you get the feeling for working with arrays of PVectors, you'll find that it really is a great conceptual tool. It helps you think at a very high level, and you can just think about your objects as these big collections of points. And you don't get bogged down in details of having an array of x and an array of y, and you have all these loops, and you have to type everything twice because you have to do it once for x and once for y. The PVector really is a convenient way of packaging all that information in one place.